present in manganese sulfate, where let us try the oxidation state of manganese in manganese sulfate. Okay, so MnSO4. We know for sulfate it is -2. You can take like this very simply. Sulfate is a divalent anion. Therefore, put X, you know very well X -2 is equal to 0. So X is equal to +2. That is the oxidation state of what? The manganese present in manganese sulfate. So the first and the foremost thing you are supposed to do is you have identified the element that undergoes oxidation number. Okay, so manganese has become Mn plus 7 has become +2, plus 7 has become +2. Okay, so it means +7, that is it has come down to +2. So what do you understand from this? Being an oxidizing agent, it undergoes reduction, is it not? So decrease of oxidation number is reduction. So you can indicate the reduction by H. Now let me recap the oxidation aspect, oxidation and reduction. So oxidation and reduction. Let me talk about this before solving this problem. Oxidation and reduction. Simply you can remember that addition of oxygen is oxidation. A removal of oxygen is reduction. And removal of hydrogen is oxidation. Addition of hydrogen is reduction. And de-electronation, that is a removal of electron, is oxidation. And the addition of electron is reduction. Increase of oxidation number is oxidation. Decrease of oxidation number is reduction. Similarly, oxidation is an anodic process, so you can put anodic reaction, whereas this is cathodic reaction. This you have to memorize, okay? Don't forget. So this is for your memory, okay? Right, now let me come back to the main problem. Here, there is a decrease in oxidation number, so it is a reduction. Do you understand now? Now let us check. And how about the addition of electron here? So +7, how many electrons are added? 5 electrons are added, and that's why it has come down to +2, is it not? So the addition of electron can be represented by an upward arrow like this. By how many electrons? +7 has become +2. So 5 electrons are added. Do you understand? E means -1. So 5, it means +7 minus 5 is equal to +2. Do you understand this? Right. Now let us come to the oxalic acid. What is oxalic acid? Here let us check the oxalic carbon in oxalic acid, the oxidation number of carbon in oxalic acid. Okay, H2C2O4. H2C2O4. So in H2C2O4, we need to find out the carbon oxidation number of carbon. So this is -2, this is +1. So 2 plus 2x plus 4 of -2 is equal to 0. So 2x minus 8 plus 2 is equal to 0. Therefore 2x is equal to +6, is it not? So 2 minus 8 minus 6, it becomes +6 when it comes on the RHS. Now x is equal to 6 by 2, that is +3 is the oxidation state. So you can mention +3 is the oxidation state in oxalic acid. And similarly, let us work out the carbon dioxide present on the product side. So you know this is -2. So naturally what? This is x. So x minus 4 is equal to 0. X is equal to +4. So +4 is the oxidation state for carbon which is present on the product side. So this is +3 and that is +4. Okay. So let us mention that one also. So this is +3. here. So this is plus 3 and it has become plus 4 here. Okay. So let us put by a bracket, I mean arrow mark like this. And this plus 3 increases by plus 4, is it not? Plus 4. Therefore, it is an oxidation reaction. Okay. So by a drop of how many electron? One electron. But how many carbon atoms are there? Two carbon atoms. So you have to multiply by 2. Okay. So far we have identified, okay, which undergoes reduction, which undergoes what? Oxidation. See, oxidizing agent undergoes reduction, whereas reducing agent undergoes oxidation. Okay, right. And you may ask me, sir, what about sulfur? Sulfur doesn't undergo any change in the oxidation number. Okay, what about this hydrogen? Yes, it doesn't undergo any change in oxidation number. You can very well check. You can very well work out and check. Okay, now let us come back. So the next step is we need to multiply these two. I mean, that is a 5 electron and this is 2 electrons. We had to cross multiply, that is crisscross. You can adopt a crisscross. Okay, it means exchange, not multiply, exchange the number of electrons. You just follow the rule, exchange the number of electrons, okay, as molar coefficient between the participating what agents. So this is oxidizing agent, this is reducing agent. So you can interchange the number of electrons as molar coefficient. So in that case 2 electrons, so 2, so we have to write 2 K1O4. And what about this? This is 5H2C2O4. So let us comfortably write nearby so that it will be easy for you. So 2 KMnO4, are you able to follow? 2 KMnO4 plus, and here 5H2C2O4. The important secret is once you have fixed this, you are not supposed to change it. Okay. So 2 KMnO4, 5H2C2O4, and you have H2SO4. Then you continue. So this is K2SO4 plus MnSO4 plus CO2 plus H2O. Okay, right. Now again you can adopt the ERP method, that will be very convenient for you. So let us work out. Okay, so what are the elements present? As I already mentioned, that is you need to give importance to what? The element which is present in less number of places. Okay, so let us focus on the cation. Main cation here is manganese. So let us put manganese. And the other main cation here is carbon. So put carbon. And then other things, other elements can be followed. Okay. And what about oxygen, which is widely distributed? So it should be given the least priority. Okay. So attack like this. For instance, you got a lot of papers kept on a table. When any fellow comes and switch on the fan, what will happen? The ceiling fan, what will happen? It will fly everywhere. These papers will fly everywhere. The best thing, will you be collecting these papers one by one? Best thing is go just switch off the ceiling fan. That is the simplest way. Instead of searching or driving behind the scattered things, and that is why we should always focus on the single entity instead of that is going behind the multiple and diffusing elements. So here oxygen is widely distributed, don't take that, it will get balanced by itself. Now manganese, carbon, and what is the next target to us, which is less distributed? Shall we take hydrogen? No, because hydrogen is present here. What about sulfur? Yes, sulfur is also present here. So there is no other go. So let us go for hydrogen and sulfur. Okay, hydrogen, sulfur, and finally you can put what? The oxygen. So sulfur and hydrogen, finally you can put oxygen. Now we have to count how many we have left the main element, that is potassium. Okay, we can put potassium. Okay, right. How many elements are there? Manganese. There are two manganese. Okay, so there are two manganese on the left side. And what about here? There is only one manganese. Then what about potassium? There are two potassium. What about potassium here? There are two potassium here. Okay, and carbon 5 twos are 10. So we can put 10 carbon here. Is it not? So 10 carbon here. And what about this side? There is only one carbon. Okay, right. Then what about sulfur? The sulfur, you have got one sulfur here, one sulfur. So sulfur 1, and here you can write 1 plus 1 instead of writing 2. Okay, because we can comfortably tally these two. And then because sulfur is here and here, so 1 plus 1. And what about oxygen? Oxygen, there are 8 oxygen plus 5 fours are 20 oxygen plus here 4, is it not? 4 oxygen. And what about here? That is 4 oxygen plus 4 oxygen, don't combine, plus 2 oxygen plus 1 oxygen. Okay, so this is the way it is distributed. So since oxygen is widely distributed, let us not give importance to that. Okay, right. Now let me go with the manganese. I mean potassium is already solved. Okay, tick. Then what about manganese? It is 2, here 1. So shall we multiply by this 2? So when I multiply this, immediately you have to multiply the manganese also, because I am multiplying this by 2. So 2. And immediately sulfur becomes a 2 sulfur, is it not? So I have to identify this manganese, that is in the second place. So put 2. Okay, right. And what about oxygen? You can come here straight away, 2 into 4. So 1, 2. So 2 into 4, 2. Okay, right. And then here, leave it as it because it's already there. So when I disturb anything here, it should be compensated immediately in the ERP table. And then, so carbon, what about carbon? 10 carbon. Okay, so 10 carbon means 5 twos are 10 carbon. Okay, here I'm sorry, 5 twos are 10 carbon. Okay, and what about this? Only one carbon. So simply put multiply by 10. So you can put 10 here. Immediately 10 into 2, is it not? So you have to multiply this by 10, is it not? So 10 into 2, finished. Okay, right. And then, so this is also balanced. Okay, now let us come to sulfur. What about sulfur? Sulfur I have, this is 2. Okay, 2 sulfur, and this is 2. So these are all already fixed. Okay, so 2 sulfur. 2 plus 1, 3 sulfur. So 2 plus 1, 3 sulfur. So I must multiply by this 3. So you can put 3 here. Okay. So when I put 3, immediately it becomes what? 3 sulfur. It is okay. 3 twos are 6. So where is hydrogen here? So I should target hydrogen here. Okay. So I have not written hydrogen here. So let me write here. So here 5 already. In this case, 5 hydrogen means 10 hydrogen, is it not? 10 hydrogen plus, and here that is 3 into 2, is it not? Already it was 2 into 3. Okay, so 3 twos are 6. And what about the hydrogen present here? The hydrogen, it is present at only one place, so I can put simply 2. Now I have to tally all these things. So 3 into 1, 3. So sulfur, it is finished, and hydrogen I put 16. Okay, 6. So total is 16. Now my target is I have to increase this. So 2. So let me balance this by 8. Okay, so I can put 8. So when I put 8, immediately I have to put here also. So here over. Okay. Now sulfur is worked out, and what about this? Hydrogen is balanced, and this one. And when you look at this, you just to check it up whether we have done everything, and here we are not done because 3 into 4, is it not? So 3 into 4, because you are done multiplication by 3, so 3 into 4. Okay, now let us check oxygen. Oxygen to 8 12, 40 oxygen totally, is it not? What about here? That is 4 plus 8, 10, 20, I'm sorry, that is 8. And what I have done here, so here also it comes 8 plus 12, 40, and this one 20. So 8 plus 12, 20 plus 20, 40. Okay, 40 oxygen. So this is also balanced. Okay, so all are balanced. You can check it out. So see, we are not specifically gone behind oxygen, but it is automatically balanced here. Do you understand this? So this is known as the oxidation number method of balancing the redox reactions. Okay. So we have two more methods remaining. So we have completed the normal ERP method and redox method. Okay, that is oxidation number method in solving redox equation. And we have these two more methods, so that will be discussed in the next class. So before that, let me have a summary of entire thing what we have discussed. See, in the first method, that is nitrogen combines with the hydrogen to form ammonia, where you just list out the elements, and here how many reactants or the products are there, and individually you can balance it. Okay, and the most important thing is the widely distributed element should be given the least priority. Okay, right. Now oxidation number method. In oxidation number method, let me consider acidified KMnO4 reacting with the oxalic acid to give potassium sulfate, manganese sulfate to carbon dioxide. So we need to identify the element that undergoes change in oxidation number. So determine the oxidation number which undergoes change and identify by the respective reaction. And then what you are supposed to do, you have to identify the number of electrons that is transferred during this redox reactions. Okay, so just by crisscross, what you have to do, you have to interchange, okay, the number of electron transferred to the neighbors as molar coefficients. So once fixed, don't change it. Then you go ahead with the remaining and you can adopt the element reactant product technique. Okay, so where you can put, as I already mentioned, the priority should be given to cation. Okay, so you have to give cation and finally anion. Okay, and if the anion among the cation, which should be given importance, that is the one which is present in the least position should be given the high priority. The one which is widely distributed should be given the least priority, and that is why hydrogen is given the least priority, because it is widely distributed. And what about oxygen? It is much widely distributed, so don't worry about that. That will get balanced by itself. Okay, so attack like this and it will be very easy for you. So you have to practice many sum like this, and I'll give you the list of equations, list of redox reactions to be balanced in my next class. Okay, and in my next class, don't miss that class where I'll be discussing very important technique, that is the ion electron method, followed by some algebraic, that is mathematical technique to balance the chemical equation. Okay, so thank you for your patient watching of this class. Okay, and always subscribe to Saitechinfo so that you will get subsequent videos. Thank you very much.